Hello again, Meridian. I hope that you had a good break. Our quiz question this break was actually a really hard one. I got to admit, I did not know the answer myself. It was, what was the root account seed before Stellar had network passphrases? And the answer is, all my life, my heart has been searching. Now, you're going to have to verify this yourselves, but I think that's a paraphrase of a Hunter S. Thompson quote. Early Stellar, Gonzo. And with that, back to Anchor Day. Now that, thanks to Tomer, you know the sordid history of Anchor interoperability, it's time to get technical. In 2020, our next speaker, Jake Urban, software engineer at SDF, put a ton of great work into Polaris, which is an extendable Django application for building modular Stellar Anchor services. Now, that's a mouthful, and I will let Jake explain exactly what it means, but I can tell you this, it makes setting up an Anchor service a lot easier. Jake, the floor is yours.
Hey, thanks, Justin. So yeah, I appreciate the intro because this is going to be a fairly technical conversation or presentation. But like every other video during Meridian, this is going to be available to rewatch on meridian.stellar.org or later this week on YouTube. Let me begin by just saying to Justin, I don't see my presentation. I actually see you. There we go. Okay, cool. My name is Jake Urban. I'm a software engineer at the Stellar Development Foundation, and I'm going to talk to you about building Anchor services with Polaris. And we're just going to jump right in. So this is our agenda. We're going to talk about what Polaris is, how it works, and then we'll dive deeper into Polaris's data model, and then how you'd go about implementing SEP 24 and SEP 31. At the end, if you have any questions, make sure you just type them into the QA bar up top of your chat window, and I'll be sent them and I'll answer your questions. So what is Polaris? Polaris is an extendable Django application for building modular Stellar services. And that is a mouthful. And so I'm going to start on the Django piece in case you aren't familiar. Django is a Python framework for building applications. In Django, when you build a Django project, you start with a Django project, and you can add and remove any number of apps within your Django project. And these apps are kind of self-contained units of functionality. They come with fully implemented database endpoints, database models, API endpoints, and views for the users, viewing them on the browser. Each app is a self-contained application, and the Django project houses all of these applications that you install within your Django project. Polaris is a Django application, so you would install it alongside any other app that you have in your Django project. A very common pattern is to have the Anchors app that has its own database models, its own endpoints, and its own views. And then alongside that, it would have Polaris, which has its own, it again has its own database models, views, and endpoints. So let's actually get into what Polaris is, or what the guiding principles of Polaris are. Polaris is extendable, and that's really one of the biggest points. Polaris implements functionality common to all anchors, but nothing more. And so what that means is that Polaris, there's a set of functionality that all anchors are going to need to implement, but there are pieces of functionality that only the anchor can implement because it's specific to the anchor. And we'll go over that in more detail in a second. It's also comprehensive. So Polaris focuses on transfer SEPs, so specifically SEP 6, 24, and 31. Each of those three SEPs depend on SEP 1 and SEP 10. Some of them depend on SEP 12 as well. It's pretty comprehensive. If you want to build an anchor service, Polaris has the SEPs and supports the SEPs that you want. So that's great. And if there's a new SEP coming on, we will build it out within Polaris. And then I touched a little bit on this when I was explaining Django, but Polaris is modular in its own right. So just like a Django project has several apps that run alongside each other, you can have several SEPs active in a Polaris instance. So you can choose to have a SEP 1 support active on Polaris. You can choose to have, in addition, a SEP 10. You could choose to omit the SEP 10 and just have SEP 1 and SEP 24. It's completely up to you. Each SEP that you deploy or activate via Polaris is completely independent of one another. And I'll talk more about that as we go on. So now that we know kind of what Polaris is supposed to be, how does it actually work? Well, Polaris implements all it can, right? So it, like I said earlier, it has this kind of baseline functionality. Everything that's common to all anchors is implemented in Polaris. And so it does this through a database model, a user interface, and SEP APIs, right? So it actually implements a common design pattern that engineers should be familiar with, is the model view controller design pattern. This is essentially just saying that an application has its data model, a user interface displayed to the user, and then it has a controller, which is really the meat of the application, where it actually performs all the actions that you would expect the application to perform. And so Polaris, along with most Django applications overall, conforms to this pattern. And when you're developing on Polaris, you develop alongside that pattern. So Polaris implements all it can, and anchors implement what Polaris can't, right? So Polaris doesn't create the asset for you, right? You have to issue the asset on the seller network. It also can't configure the signing configuration on your account. You have to decide if you're going to have a single signer configuration or a multi-sig configuration. If you don't know what that means, don't worry about it. It also doesn't know what bank or payment platform you use, right? An anchor in Brazil uses a different bank and probably a very different API than a US anchor. And so Polaris doesn't make any assumptions about what payment platform you're using, but it does provide interfaces for anchors to inject their custom functionality to connect to those platforms. There are a few more examples, like collecting KYC information. Every anchor needs different KYC information. Some anchors may just need an email. Others may need a social security number, or maybe a liveness check to make sure that you're actually a real person. This depends on your, the country that you're operating in and the legal requirements that you need to satisfy. And then finally, Polaris doesn't know anything about your users. It doesn't track any user management, and it doesn't try to engage your users outside of the actual SEP. So if you want to send your users email confirmations, or you want to, allow users to recover, in an external, account on your own platform, that's all done outside of Polaris. So this is something that you would build into Polaris or alongside Polaris. And so Polaris implements all it can, anchors implement what Polaris can't, and that's kind of the baseline of what an anchor is, right? That's the minimum. Anchors need to implement some subset of functionality because Polaris doesn't know what you need as an anchor. But on top of that, anchors can also customize and extend Polaris. So if you feel like Polaris' data model is lacking and you want to store more information, you're free to add more database models. If you don't like the way that Polaris, if you don't like Polaris's UI, Polaris comes with a default UI that's halfway decent, I would say. But if you don't like it, you are free to change it. And then also, if you have external functionality that you want to offer to your customers, but Polaris doesn't offer it, it's not a part of any one SEP, you're free to define new endpoints just right alongside on the same server running on Polaris. So an example would be like if you want to have an email confirmation endpoint where you send an email to your user when they sign up, and then they click a link and it hits an endpoint on your server to confirm that the user owns that email. Polaris doesn't do that, but you can definitely add an endpoint alongside Polaris to do that. Okay, so now we're going to get into more the technical bits of Polaris. So this is Polaris' data model. Don't try to read that picture, but it's really just to show that there are two tables, assets and transactions. That's really it for Polaris' data model. It's fairly simple. And the good news is that it can be configured for any relational database. So it comes with SQLite 3, which is really common for local development. And then it comes with Postgres SQL support or Postgres SQL Postgres support installed. So when you do a pip install Django Polaris, it comes with the drivers for Postgres as well as SQLite. If you want to configure it for MySQL, you're more than welcome to. You would just have to install the driver in addition to Polaris, and then configure your settings to use the MySQL engine. So let's talk more about assets. So obviously, when you anchor an asset on the network, you would need to have a local representation of that asset in your database. So every asset that you anchor needs to have a row in your assets database that corresponds to it. Polaris can anchor any number of assets. So you can anchor 1, 2, or n number of assets using Polaris, And each asset has its own signer configuration. And you can, by default, single signer configuration is simple, and it just involves a single master key. If you ever use Stellar Laboratory or created an account, this is the default. This is the default configuration. You can also add additional signers to your accounts that control the supply of your asset for added security. And then on the right, there are some key columns here. I'm not going to go too deep into this, but obviously you need a code for your assets, such as XLM, SRT, USD, the issuer address for the one that issued the asset, and then the distribution seed or private key. This is really the account that has or controls the supply of the asset that you control. And we make sure, Polaris makes sure to encrypt this seed at rest, but it is unencrypted in memory. There are some other more meta columns, as you see, but I'm not going to spend too much time on them. They're fairly self-explanatory. Okay, so let's talk about transactions. So there should be a transaction database record in your database for every client request for a new transaction. So a wallet or a client is going to ping your Anchor service and say, hey, this user with this account wants a deposit, wants to deposit money onto the Stellar network. And that should trigger a creation of a transaction database object in your application. That transaction object is then going to be used to track the progress of that transaction throughout the entire flow. Note that the transaction in your database is created well before a transaction is ever submitted to the Stellar network, right? So when a client originally says, I want to make a deposit by making an HTTP request, the transaction is created, but you don't know who the user is. You don't know how much you need to transfer. You don't even know, actually you do know what asset you want to anchor or what asset is being transacted, but you don't know enough information to actually facilitate the transaction. So the client initiates the deposit, you collect the information necessary, and then you actually facilitate the transfer by submitting a transaction to the Stellar network. This example I'm using as a deposit flow, and we'll go in more detail in a second. It's also pretty common for anchors to add additional information to a transaction. So, if you don't feel like the transaction model that Polaris has stores the information that you would like, you can have another model that has a one-to-one mapping to every transaction, and you can add the fields that you need on top of what Polaris provides. And again, there's some key columns on the right here. Every transaction has a unique ID. Every transaction transacts an asset. And then the very important status column communicates where in the flow or how far through the processing flow the transaction is. So originally it's incomplete. Then it's up to the user to actually send the money to the anchor. And then once the anchor has the funds, it's up to the anchor to actually make the transaction on the Stellar network. And finally, it's complete. There are some more columns, but hopefully they're fairly self-explanatory. And you can check out more in the documentation that I'll link at the end of this presentation. Okay, so now we know kind of the basics of what Polaris is, how it's supposed to operate, and kind of the base data model that facilitates everything that we're going to talk about in the next couple of slides. Now we're going to talk about SEP 24. And if you're unfamiliar with SEP 24, what it really is a transfer, one person's transfer of value from one account to another. And both these accounts are controlled by the user. So it would be like if I have cash in my wallet and I go and transfer that cash from my wallet into my bank account by going to an ATM. In the same way, you may have you may have money in your bank account and you want to transfer that on the Stellar network. SEP 24 is what does that. It moves your money from an off-chain account into an on-chain account. And this doesn't have to be a bank account. It can also be another crypto network. So if you have BTC on the Bitcoin network, you can go through a Bitcoin anchor, send your Bitcoin to the anchor, and the anchor will put BTC on Stellar in your Stellar account. So it's really any kind of asset. Traditionally, it's either fiat or crypto. Okay, so this is kind of the high level flow of SEP 24. You need to, or the client, the application, the wallet, needs to prove to the anchor that it has control of the Stellar account for which it wants to deposit funds into. So this is done via SEP 10. We're not going to go over SEP 10 in this presentation, but it essentially just proves that the user has a Stellar account and that they control the account either by having a single master key or by having the sufficient signers necessary to reach the medium threshold of the Stellar network, which is a medium threshold. Basically just proves that you're able to perform certain actions versus like the low threshold. Once a anchor knows that a user controls an account, the wallet or the client needs to initiate the deposit. So we talked a little bit about this prior, but the client makes an HTTP request to the anchor specifying that, hey, I want to make a deposit initiation request for this asset. Now I need you to return me a web app so I can open it to my user and they can enter all the information that you need to collect, right? So that's what it does. It says, hey, I want to make a deposit. The anchor says, okay, here's a web app via a link. Open this link to your user, and then I'll let you know when you can close the link. And so during that time, the anchor renders a link or a web app in the actual user's UI. This differs from step 6, which is slightly different, and it doesn't actually open a UI from the anchor. The wallet is the one that actually collects all the KYC information, but that's a talk for a later date. Once the anchor has collected all the information on the user and they're ready to facilitate the transaction, they just wait for the user to actually send the funds to the anchor. So if the anchor just waits. So if the anchor is anchoring fiat currency, say you're anchoring a US dollar, you would wait and just watch your bank account for a payment to come in from the user that initiated the deposit. You would do this either by communicating a reference number to the user or by some other mechanism, but you would match the payment made in your bank account with the initiation deposit request made by its client. Once you've matched the amount sent with the user who made the deposit initiation request, you should have all the information necessary to complete the deposit. And this involves constructing a Stellar transaction and submitting it to the network. And that's it. Money transfers from somewhere off chain. It's sent to the anchor. The anchor matches it with the user who sent it, and then makes the corresponding transaction to the user on top of the network. So Polaris has integration functions, and these are really, really important for understanding how Polaris works. So like I said, Polaris implements all it can, and then anchors implement what Polaris can't. And anchors implement what Polaris can't through integrations. So Polaris offers a programmable interface for anchors to code their custom functionality, and Polaris calls those functions so that it can execute on that functionality. So the one example I'm going to use is KYC and transaction information collection. So the Polaris doesn't know what information you need to collect. You may just need to collect an email and the amount that you want to transact. You may need to actually do like a liveness check where you actually open up your video and confirm that it's an actual person. All this stuff can be done through Polaris by basically defining a form and then returning it in an integration function. Polaris will call that integration function and render the form passed to the user. So Polaris almost acts as like a mediator between the anchor and the user by facilitating the majority of the functionality, but the pieces that Polaris can't implement, it calls functions for and then uses that content to move on. There are also deposit integrations, which are like post-processing. So like when a deposit is submitted to the network, you're able to do any kind of like cleanup or notify the user that the deposit was complete. And there's also Rails integrations or payment Rails integrations where you actually connect to your bank and check for incoming deposits or check that a transfer or withdrawal actually made it all the way to the user. These are all integration functions that you can explore in more detail on the Polaris documentation. So Polaris is also a multi-process application. It doesn't just run a single API server. The API server is really what is the interface. That's what clients interact with. But behind the scenes, there are other processes doing other tasks that are important. And so this, in the case of deposit, is a deposit detection polling process. So you're going to have an API server that is responding to requests from clients, but you're also going to have a process running in the background that is continually polling your bank account or your crypto address or wherever you're watching for incoming payments. And when you have an incoming payment, this is where you match it with the user and then continue on. So this other separate process basically just ensures that you don't have to spend time checking for deposits while other clients are waiting for requests. You can do both at the same time using the multi-process architecture. And for those of you familiar with like Node.js and more asynchronous event loop style frameworks, Polaris and Django are synchronous frameworks. They don't have an event loop type architecture, so you need to have separate processes for these types of jobs. Okay, so Polaris offers a default UI as seen on the right here. This is just a simple form asking for the amount that you would like to transact. And Polaris, provides that default. If you like it, you don't need to do anything. It comes with the default UI and it's all good. If you don't like it and you want it to be more in line with your brand, you are more than welcome to change everything. So anchors can change the default UI by adjusting the CSS style sheet. You can define your own Django forms like I touched on earlier. So you can add not just the amount, but you can add the bank account number or whatever else you need to collect. And then additionally, you can also add arbitrary content to the actual HTML page and just inject any kind of script headers or body content that you want. Okay, so that was deposits, and we kind of went over the UI that it shows when you go through deposit. You also see that UI for withdraw, and we're going to go through the flow of withdraw now. So, and if you actually look at this slide, it's identical to deposit, and that's because the high level steps are the same. The user needs to authenticate. The client initiates the withdraw by making a request to the anchor saying this anchor wants to make this user wants to make a withdraw from the Stellar network, and then the anchor begins to wait for an incoming payment. Now the difference is that in withdraw, money is going from the network, from the Stellar network, off chain, right? Deposit, you're going from off chain to the on chain, and for withdraw, you're going on chain to off chain. So in order to detect a withdraw payment, you need to watch your Stellar account, right? A user is going to make a transaction and send US dollar tokens to the Stellar account of the anchor. The anchor is going to detect that payment, match it with the user that made the withdrawal initiation process, and then finally complete the withdrawal by transferring the value sent to their account off chain, either by a bank transfer or by notifying the user that they can go to a physical location and pick up cash. Whatever it is, the high level is that it goes from on chain to off chain. Again, just like deposit, withdraw has integration functions as well. I'm not going to go over these in too much detail. They're very similar to deposit. Again, the difference is just the direction of funds. So there's slightly different integration functions, but many are the same. Withdraw also requires separate processes. So just like the deposit had a polling process looking for incoming payments, withdraw also has a detection streaming process, streaming transactions from their Stellar account. It also, once you receive payments on Stellar, you make outgoing transactions off chain by using the executor, and then you check on those transactions by polling and making sure the user actually received those funds. So for example, if an anchor receives a payment of 20 US dollar tokens, that anchor would then match it with the user and then send 20 US dollars via bank transfer to the user. Now, the reason we exist, the reason Stellar is here, is because the current system isn't very good. And so it can take a long time. And that's why you have this polling process. It makes sure that while the funds are en route off chain, they eventually arrive at the destination. And then that would be when you notify the user that the funds have landed in the account. Okay, I'm going to talk a little bit about cross-border payments on Stellar. You can think of the difference between SEP 31 and SEP 24 is that SEP 24 is between one user. It's just one user moving his funds from one of his accounts to another account. And those accounts, one of them is on-chain, one of them's off-chain. In SEP 31, it's actually between two users. So you're actually making a payment from somebody, from somebody who has the funds to somebody who wants the funds. And this is done and facilitated by two different anchors on the Stellar network. A good analogy is that the SEP 24 is like depositing cash into an ATM to put into your bank account. SEP 31 is like a traditional wire transfer where you send money from one person to the other and it just ends up in your account. The beautiful thing about this is that users don't need to even know about Stellar. They can just assume that the anchors are taking care of it send the money over, and the money just lands in the recipient's account. One more analogy I'll use is that you can think of SEP31 almost like a SEP24 sandwich. The first part of SEP31 is a deposit. The sender gives money to the anchor, and the anchor matches it with the sender. Then you have this kind of middle meat of the sandwich where the anchor makes another payment to a recipient anchor, and this recipient anchor finally makes kind of what would look like a SEP24 withdrawal to the recipient. So they're different protocols, but the analogy stands. You can think of it as like a deposit, path payment, withdraw. SEP31 has a slightly different flow. I'm not going to spend too much time on the architecture of SEP31, but the idea is that you still use SEP30 or SEP10 authentication. You register customers using SEP12 this time. You don't actually, the anchor doesn't offer an interactive flow. This is all done via API calls. Remember, the user doesn't need to know that Stellar exists. So it doesn't really interact with the receiving anchor. It really just interacts with the organization that's collecting his money, so that, or his or her money, so that when the money is collected, that anchor can send the money to the across the world to the other anchor, and the other anchor can finally transfer that value to the recipient. SEP31 also has integration functions and other processes. Again, they're very similar to SEP24s, but the difference between SEP24 and SEP31 is SEP31 is this kind of all-encompassing off-chain, on-chain, off-chain flow between two users, whereas SEP24 implementation is between one user, just going from on to off or off to on. And that's really most of the content I have to present to you. I'm sure that was a lot. If you have questions about Polaris, feel free to ask them in the QA bar, but we also have pretty good documentation that you can explore on readthedocs.io. We also have a test anchor.stellar.org. So we call it an open source Polaris server. It's available at testanchor.stellar.org, and you can ping this service to test out your client application. In the same way, we have a client application that you can use to test out your anchor. So Stellar wants to make it super easy, and my team in particular wants to make it super easy for you to build anchors and wallets so that we have this beautiful nirvana of interoperability on the Stellar network. If you have any questions, feel free to ask them now.
Yeah, Jake, we have about 4 minutes left, so there's not a ton of time for questions, but we have gotten a lot in, and I'm just kind of going to bunch some of them together. I think what a lot of people are interested in is who should use Polaris? Like, what are the use cases? Should you build your own anchor service from scratch? Does it work for non-issuing anchors? Does it work for people who don't issue fiat currencies?
So there's a lot there. So so generally anybody can use Polaris. It doesn't matter if you're a major corporation or a small company. Generally, larger corporations are going to want more control over their application, and so maybe Polaris might not be the best fit because they want more fine-grained control. Polaris does a lot for you that larger corporations may want to do. You can also anchor crypto. You don't need to anchor fiat. It's really any asset, and it's super easy to get started. I missed the rest of your.
Oh yeah. So someone also said, Tomer just mentioned these non-issuing anchors. What does Polaris serve them too?
Yeah. So Polaris really just needs to know the issuing address. It doesn't actually need to do anything with the issuer account. So you can anchor somebody else's asset. And so say Tempo issues EUROT. You can anchor EUROT. You can anchor Tempo's EUROT. You don't need to actually invent the asset yourself. You can just use something that exists out in the ecosystem today.
And again, there's several questions that also fall into this category, which is what's next for Polaris?
Yeah, so Polaris is meant to kind of be this catch-all for building anchor services. So if there's a new SEP, we will build out the functionality there. And one thing that I've been really focusing on, I've been building Polaris for the last year or so, but it's been mostly me. And I can keep building it, but I would love to have more community engagement, more community contributions to build out Polaris. And at some point, I would love to completely relinquish control and just allow this to be a community tool. So that's the end goal. And the Stellar Development Foundation and my team are doing other things. So at some point, I will not be doing as much on Polaris, and I will be relying more on the community.
And if someone out there hears you right now and says, well, that's me, I want to get involved, what's the best way for them to get involved?
Just check out the code and then make a pull request for any changes you want to have. It's very easy. It's very similar to any kind of GitHub collaboration effort that you've been a part of before. If you want to get in touch with me personally, I'm available on Keybase, and we can just continue to talk there.
Great. Yeah, I mean, it's amazing to see how far Polaris has come, and this was really, really enlightening. And it's super exciting to think of it like continuing to move forward and being propelled by participation, which is, feels like what Stellar is all about. But it's also really amazing how easy this is making it for anchors to set up. It really feels like a game changer. So thanks so much.
Absolutely.
Thanks so much, Jake.